Hi, I'm Tom and I talk about code. Welcome to another compiler live stream. We're using Rust, building a C-like compiler, and for the last 4 streams I've been working on structs, and this is going to be yet another struct episode. We're getting really close to fixing structs. It's pretty exciting. Last time we did a lot of really good work to refactor the left-hand side of the equals sign. And that refactor is looking really nice. Let's jump over and have a look, because I pulled this out into a function. So this is now a function that we can reuse, and hopefully we're going to reuse it to fix the left-hand side of the structs, because currently we have a test that fails. We have a test, and I've stepped through this in the debugger off camera to work out exactly what's going wrong. I know what we're doing. So if I look quickly at this test, what we're trying to say is we make a variable foo, which is of type foo, which has a field x and bar, and we're trying to get foo.bar.x. We set it to 5. Now this works. This is correct. If we pull up this, kind of running in the machine, I've stepped through it. That's kind of this chunk of the code. We push 5 to the stack, which is the thing we want to write, the value on the right hand side, and then we get the base of the base pointer, we add 0 to it, so this kind of gets where in the stack frame the address of foo is. We add 2 to it because bar has an offset of 2 in this struct, and then we add 0 to it because the field x has an offset of 0. Eventually we're going to filter out these instructions as no-ops, we're just not going to do them, but for now we omit them into the program, and it actually makes it a lot clearer what's going on. If these weren't here, it would be much harder to debug. So we can see that we pop what we had in the C register before into the B register. Again, eventually maybe we're going to be able to, just not use the stack and keep this in a register the whole time, but that's okay, and then we store it in this address, so that works correctly. But then when we try and load it back, some really funky stuff happens. We get the base of the struct foo, but then we load it as a pointer, which isn't right. So what that says is, we kind of treat, like, we start with the offset of foo, and then we go straight to the value of x, and then everything we do there is relative to the value of the field x, which is going to hopefully be 0, but we don't really know because it's on the stack, it could be anything, and so it gets corrupted. And actually what we end up returning is the offset of the field bar, which is kind of weird, or the offset of the field x in the nested struct overall. So it's weird, something strange has happened, and I thought, when I look at the code for this code gen, if I jump up to not here, I think I called this like field deref or something really silly. It's not a good name. Let's put a mark here as well. I'll make this mark Z. So I have A, I have Q, I have Z. I'm going to try and be better with not overriding my marks. I've really struggled to have mark consistency, which is funny given my name. So field deref, I tried to have this recursive thing where we had the left-hand side of the expression. So right now this kind of gets evaluated. It's like foo.bar.x. Well, this is foo.bar.x. So let's evaluate foo.bar. Well, this is foo.bar, and step through it like that. But this actually results in a lot of complications that aren't there if we just iterate this over as a list. So we're going to jump in, we're going to find our field deref, and we're going to make this look like the right hand side as well. So instead of a box, we're going to have a vec of identifiers. And that's it. So it's going to be like foo.bar.x. This is just a list of fields. This has a lot of implications. This changes things quite a bit, but that's okay. So to print this out, it's actually going to be a little more complicated. I'm going to need to write something here. It's going to be like fields.iter. Or maybe it's actually just fields.join. Maybe I don't need to iter. And we're going to join them with a dot. So it's a little bit more complicated. It's not much more complicated, but it's a little bit more complicated. And then we're going to have to change the parser as well, because field deref, when we do this here, like I had to do something very clever to make this work, but because I had that whole recursive issue I think 2 streams ago. But now we're actually just going to give back the simple thing. We're just going to say ast expression field deref, and we're going to give back the fields that we passed. And that's all we do. We get rid of this stupid thing, and all of our recursive nightmares have gone away. So if I build this, it's going to yell at me about a bunch of stuff, I'm sure. Mostly in this one spot, which is nice. So this is all the code that we're going to change anyway. This is somewhere else. The method join exists for reference. but its trait bounds were not. Oh yeah, well that's okay. This is because fields are not strings. They are not too stringable because they're this weird wrapper type. And honestly, the best way to fix that is probably... Actually, identifier is stringable, which is weird, right? Identifier doesn't implement join. I would have thought anything that implemented toString could be joined, but I guess we have to do that stringy part explicitly. Anyway, no, look, let's write that, because that error we can actually resolve just like right now. And it's going to look really silly. We're going to have to iter, we're going to have to map to string. We're just going to convert it to a string, and then we're going to collect it into a vec. So this is quite wasteful, and then we're going to join. Cool. And that now works. That now works wonderfully. Resolve also references this somewhere. Field deref. Oh yeah, okay. So this works a little differently now, and this is kind of good as well, because it's no longer, it no longer does this like recursive type of. So, how do we get the type of this field? Well, now we need to do it iteratively. So we need some kind of loop for field in fields, except we probably want to look at everything after the first one. We're probably going to have to get the type of the first field first. So let's say let head type equals type of, we want to get from the scope as if this was an expression, as if this was just a free variable, fields dot first head, I think it's first, right? And we're going to unwrap it, because if we don't have anything here, that's a parser error. The parser has blown up. Okay, so we'll get the head. Is it first? I can never. Okay, we'll find out when we get there. Cool. So, and let's call this let's make this mutable. So what we want to do is get the field from the current head type. So we will say type of. Oh, but if it's a pointer, we want to deref that pointer. So we're going to match type of, but if it's a type pointer t, then we're going to say if let type. We have to do this weird destructor, because otherwise it just won't work. Oh dear, oh dear, oh dear, oh dear. Actually, no, hold on. Maybe we just get the type and then we try to get the struct from it. So let's say let struct fields equals, this is better. This is less copy and paste, much less copy and paste. And this is nice because I've written this kind of shape a few times now doing structs. So it's looking good. Pingu EXOR, how's it going? Structs are hard. That's how it's going. That's roughly how my day is going. But that's okay. Like, 5 streams of building structs, I'm really starting to get a handle on what's going on here. It's going to look a lot cleaner. So we're going to grab this weird expression from here, which is all wrapped up nice and snugly in these brackets. So we get the struct fields. This looks really, really gross, but this is just unpacking either the fields of a struct or the fields of a pointer of a struct or nothing. The nothing here will blow up in a fun way, because this function, it can't return an error, so it has to return void, which is going to trigger other weird things. It's okay. It's okay. Hopefully errors will be caught before this happens, or at least somewhere else if this is the case. Okay. So we have the type of the fields. Then we need to get the actual field value. Also, this isn't called type. This is called head type. Okay, so from these fields we want to say let what do we let? Let's not get. Actually, we want to say, we'll call it next type for now. We'll say next type is struct fields. We want to get the current field in the loop from the struct fields. This is good. and then okay or, what's this called? No, it's unwrap or, sorry, yeah, this is we want to give it a default, unwrap or. If this isn't found, the whole thing is just going to have type void, and that's going to cause the entire type system to collapse on that line. Excellent, excellent. Next type. And then for the next iteration of the loop, all we do is say, all we need to say is that head type equals next type, right? Maybe we don't even need this other line. Okay, so let's try this and see where we end up. What have I got too few things? Yes. I am in dire need of another curly brace. There we go, okay. So if I build this, is it gonna yell at me? Probably. What is going on there? Next type, expected type found. Ah, type usize, yes. That's why I needed to do this on 2 lines. I kinda knew. That that would happen. Okay. Next type dot clone. So we can do this, and this breaks any weird Rust borrow checker in a loop things. Unwrap or type void. I think I need to map this actually. Let's do this. Let's map the type and the offset just into the type. Because I think I was actually doing that before. But we'll clone here, and then I can say head type equals this whole thing. Okay. Into iterator. I guess I just have to build. I have to borrow. That should be fine. But then there's going to be some weird stuff here. Expected type found nothing. Oh yeah, of course, that's because this whole thing needs to actually return a type. So we'll say head type. And that's what the type that we give back is. EQ is not implemented for identifier. That also makes sense because we need to get this as a stir slice, not this weird wrapper. That's all fine, that's all fine. Now we're really honing in on it. Variant defined here. Mismatch types, that is also okay. Again, we need to do this weird string copy thing. So we unwrap, we get the first thing, and then we string it. Actually, I think we can do it without the little in-between wrapper. Expected expression found. Ah, that, however, is not correct because the variable needs a ref. Now we're honing in, now we're honing in. And now all of these errors, so that function seems okay. Now we're in the meat and potatoes bit. We need to actually fix the field deref. So, we don't have to compile an expression anymore, that's good news. So we don't worry about that. We need out type of, so do we want the overall type? Again, I actually don't think this matters. Compiling a field dereference, we do not care about the type of the overall structure. We care about it when we're doing an assignment or something, but we don't care about the overall structure. Do we care about the fields? Not really. Do we care about any of this? No, I'm actually just going to delete this entire function because it doesn't work. It doesn't work. Okay, so this is Mark Z. So we want to copy and paste this, basically. We want to copy what we're doing in the assignment. And we'll do exactly that. We'll do exactly that. Without the compile, we should never have empty fields because this should never parse. That is okay. That feels good. That feels good. Fields.first.expect. So we want to get the first field, which again, we can expect because we've just statically asserted that it's non-empty. Headvar, or I guess dynamically asserted actually, sorry, that's the opposite of a static assertion. We get the first variable, we get the type of that, we get the stack offset of this thing. Now, so in register C is the offset of this thing, right? The memory address at which it lives. So then the next step is to deref. And to dereference, all we do is read the memory address from the C register into the C register, then we push that to the stack. So we need an out.push an unresolved instruction, which is just a normal instruction, nothing unresolved about this one, and we're going to have an instruction load word. Okay, actually we do need to know the type of this. We do need to know the type of this, because we have a helper for this as well, I think, actually. Do we have a helper? Load write value. Write value to address. Almost. Okay, so we need to know the type. We need to know the type. We need the context, we need a scope, and then we're going to grab I guess we have to wrap it up in this whole thing, which is kind of funny. Okay, so we get the type. We get the type by walking through all the fields. This becomes important at the end, because if the byte size is 1, then we're going to load a word. If it's 2, then here we'll load a byte, there we'll load a word, and otherwise we're probably going to panic because we don't know how to do that, right? You can't evaluate a struct by value. That has no meaning in my language. There is no such thing as a bare struct expression. So for example, you can't say here, you couldn't say return foo.bar. You can't return a bar. You can't return anything that isn't an int or a char, essentially, or a pointer. I guess technically if your struct was, technically I think we could return a bar in this case. The compiler would allow it because it's only 2 bytes in size, which is kind of a fun side effect of doing this by size instead of hard coding it to a specific type. So maybe that's cool. Maybe that's like a fun unintentional behavior. But if you have a type that just wraps a single field, and that single field can be returned, then you can return that type. Okay, that's actually awesome. That's actually awesome. I don't think you can use it. What does that mean if you try and use it in a binary operation? I guess it means, because all we do is push this to the stack, right? So yeah, so as long as you push it, then anything's okay. Okay, that was a rambly way to say, yeah, that's kind of awesome. But in general, we expect everything on the stack to be a word in size, right? Well, we enforce that everything on the stack is a word in size. Every stack slot is a word. Even when you push a byte to the stack, it takes up a word. It's just how stacks be. Okay, so if it's 1 byte, then we want an then we want an unresolved instruction. We're going to load a byte from register into register C from register C on the 0 page. We'll do long pointers eventually. Else if the expression type, we copy and paste this, but we do it with a word instead. Maybe some room for better reuse here. Maybe. We're gonna load a word. Beautiful, beautiful. Okay. Otherwise we need to return some kind of error. And again, we're probably going to make a new unique error type for this because I want to be very specific about what this is. And this error is, again, one of these longer names probably, value too large for stack. And we'll include the type along with this because that's helpful. So we'll say compile error value too large for stack. And we'll have the expression type. We'll clone it into this error because the error kind of needs to own it. Okay, beautiful, beautiful. And then, oh wait, hold on. Is that right? Yeah. This is right. This is right. This is in the right level of indentation. That's good. So we dereference it. So in the C register, we now have the value of that thing, and then we can just push that to the stack. Beautiful, beautiful. If you need to return a struct, you have to return a pointer to a struct, which, you know, again, you could do this, right? This would be legal. What would happen? What would happen here? I actually don't know what would happen here. What does... address of just takes an identifier. So address of needs to be changed. You currently can't do this. You could do this, but you can't do that. But even if our assignment thing worked properly, like, you know, yeah, you could this would be illegal, but this should eventually be legal. You should be able to if you need to return a struct, you need to return it. Except in that case, of course, it doesn't really make sense because foo lives on the stack frame. So once you return, that pointer's going to get mulched. Because pointers are fun. Pointers are cool like that. Okay, so we're going to go back to our code gen. So we've dereferenced it. Now all we do is push it to the stack. We push. We're going to copy and paste this because I really hate typing this many characters. Maybe it would be fun to have like a DSL for writing assembly. But I don't think that's really worth pursuing. We're going to run a stack operation. We are going to push register C into the stack, and it's going to be stack op push. Because this is how I have one instruction that does all of my stack things, because I only have so much room for opcodes. Opcodes are expensive. Okay, so if I build this now, it's going to work. Because it always works first time. 2vec, fields.2vec. Field deref. Sure, we'll do this for now. Expected a result, found nothing. Now that's because we simply forgot to say, okay, we're done, have an out. And this is gonna pass. Everything's gonna pass. I was taking the piss. I wasn't expecting everything to pass, but I am always happy when it does. Always happy when it does. Always happy. So, look at this. Look at this. Wow, I that's kind of incredible. I wasn't ready for that to be so easy. So let's write some more tests. Let's see if we can really stress this out. Let's go even harder on nested fields. Let's write a test, struct more nested fields. Let's add more nesting. Let's get a type baz. We'll do this top to bottom. Type baz, which is gonna be a struct. And one of the fun things we can actually do here is make anonymous structs. So we could say, well, let's do some padding. Let's have an int x and an int y and an int z, just to make sure that, you know, we're actually offsetting things correctly. Let's have a field called deep, and this is going to be a anonymous struct type. This struct is going to have an int x, and then it's going to have a field deeper, which is also going to be an anonymous struct, which will have a field x and a field y. Cool. So I think this is good. I think this makes sense. So now if we have a foo, we can go foo.bar.baz.deep.deeper.y. baz.deep.deeper.y. And let's make it a more distinct number. Let's make it 51 for something different. Now, will this blow up? Okay, it does. And it blows up because of a parser error. I haven't actually tried these anonymous structs before. This might just not parse. Context, new line, int x, deeper. Okay, so yeah, it's struggling to parse this. It should be okay, right? Any type should be valid. A struct definition should satisfy at the spot where any type should go. Let's just try one deep and see what happens. Let's get rid of deeper. Yeah, still doesn't love this. Okay, that's okay. That's okay. We'll do it without the anonymous struct for now. We'll write a test for that too, but that's not what the point of this test is. Oops, deeper, and deeper is going to be a deeper. Cool, and deeper is going to be, again, the same thing. Type deeper. Oh, we need to check for recursion as well, actually, because right now, if I were to say this had a field foo, we would probably have an infinite loop and add computer. We'd like open a black hole into a parallel dimension if we tried to compute the size of this thing, because you know a foo contains a deeper, but a deeper contains a foo, so it just is going to be infinitely large. So you probably need to check for that. So we won't do that. We'll just say int x, int y. Now we can say deeper. Okay, so now if we test, we also get an error. And in this case, it's because the type deeper... I'm really silly. It's really hard when you're writing a language in a language that is different. The struct has to come first. So let's say int x, int y, and then I should be able to say deep. And then this will fail when it actually runs, because Baz is an unknown type. Why is Baz an unknown type? Because I did that wrong too. Here we go, it's all coming together. So anonymous structs do actually work. And let's, in fact, continue the anonymous struct. Beautiful, okay, that does work. That was really silly. It's hard, because in Rust you write the type after the variable, and then I'm writing a language in Rust where you write the type before the variable, I can see. So your brain kind of gets scrambled, right? Nice, but that's really cool, Actually, I can make this whole test uglier and also simpler, but I'll keep it like this for now. This is good. This tests a few different things. Cool, so we're pretty confident that these offsets are working, right? We can walk this structure very confidently. Let's do one which has pointers in the middle. Let's say pointer nested fields. So we'll keep these same structs. I think that's good. But here, this will be a pointer to a Baz, and this will be a pointer to a bar. So we'll see if we can do this. Foo.bar is gonna equal 1000. We're gonna do manual memory assignment because we don't have malloc. So we just need to do some fields. And even this is a test in and of itself. So .baz, we'll put it at 1100. And then everything from there is a value. So let's test this. And that appears to pass too, which is really, really good. I wasn't sure. This one I was nervous about, but it means that we're keeping track of that state correctly, that when we need to load an address, so if we look at the code this generates, sometimes it would just have, for example, we start with the location of foo in the stack frame. We add an offset to it to find the field bar, and then we correctly load that address before we continue adding offsets. No, wait, we correctly add offsets before we continue to load values. Whatever the correct ordering of that sentence was. We appear to be doing it correctly, which is good. We write a random value into the address 1100 plus 2, 4, 6, 8, 10, 12, plus 14, I suppose. So 110D? 110D? That should be, and then we read it back, so that appears to work. Let's just change this number, because I think the more different numbers we test, the happier I am. Now, these all run in completely independent machine contexts. There's no chance that a value from a previous test is being read. They all have their own unique slice of memory. So this is really good. And I'm going to add this up because it's really good news. We're going to commit this bad boy. We're going to say len our struct expressions work LHS. Cool. And of course, that didn't commit because cargo format reported changes. So we need to cargo format first. Let's see what cargo format says. This needs to be on one line. Just putting things, yeah, in more sensible places. I love this. I'm really glad I wrote this pre-commit hook because I have really bad discipline. Of course, I forgot to actually add any of those changes, so we're gonna amend the previous commit. Struct. Cool, okay. We're just gonna push that real quick. Actually, no, we're not, because I need to type a key. Hold on. I'm just gonna quietly push that. In a different terminal, off screen. When people might still be able to sniff. I remember someone, when I was streaming back in 2021, they said that I should be careful because someone might sniff my SSH key, my SSH password key from SSH key passcode, I think is the correct order of words there, from the acoustics of my keyboard. I think like they were joking, they're a bit of a shit talker, but it was also kind of funny. Now, if you're in my Discord server, quick plug of my Discord, you can see when I make pushes in real time. They come up in a nice little feed. So join my Discord server. There are links. I think there are links in my videos. If there aren't, I'll make sure there are going forward because that's kind of cool. That's kind of awesome. So if you want to, you know, monitor my productivity, you can do so. Excellent. Okay, so I'm feeling good about structs. Now, there is an important thing. Before we can really say that structs are done, there is one test that we can't pass yet, and it's going to be absolutely critical to writing meaningful code, okay? We are going to call this something. We are going to call this nested field address. Okay, we need to be able to get the address of nested struct fields. It's just so important. So we're going to have a function main. We're going to have a type foo. Foo is going to have a couple of fields. We're going to call them X, we're going to call them Y, we're going to call them Z. And we want to, let's say, let foo. So we're going to make a foo on the stack. We're going to let a variable a be the address of foo.y. Then we're gonna set a to be 72. Then we're gonna return foo.y and expect this to be 72. Right? So we're using just this weird indirection to test that we can take the address of things properly, and this is actually so critical. So when I run this, it's gonna fail, and it's gonna fail because my Rust is invalid first. That's fun. But it's going to fail because it's not going to be able to compile it because it can't parse this. There's nothing to parse here. It can't make any sense of it. So what do we do about this? We need to change the parser. We need to change the way that an address of works in general. Now, let's have a quick look at this. Let's have a quick squiz at the AST. Because any statement that operates on an identifier, we now need to consider. Should this be an identifier, or should this be a potential dot-separated list of identifiers that represent struct member access? So for assign, we have a special case, right? We have a special field called assign struct field. And that's good. So in statement land, the only place we care, well, in statement line, we only care for assignment. You can't declare, right? The other place we use an identifier is in a declaration. You can't declare foo.y, right? That doesn't make sense. You declare the whole struct, you declare the whole foo. But when you assign, we just make it a special case. So that's awesome. That's awesome. Now, when we have an expression, the thing you're going to kind of see, right? We've kind of done this same thing because address of, variable. This uses a string. It should be an identifier to be consistent, but this wants to be its own thing and it takes a string, and that's fine. I'm not going to hate the variable definition because it's a snowflake. That's not my place. You know, I wrote it, but that's not my place. We actually have a special case of this already, field deref. Now, deref is an awful name. I really need to rename this. I need to rename this so bad, I'm going to put a to-do there. This should probably be just like struct field access or something. Variable is also an interesting name for an expression. But what this expression means is look up the name of this variable in the current scope. What this expression means is look up this dot separated list of identifiers in the current scope. So these are kind of the same thing. Indeed, like this is a generalization of this. So maybe one day this will actually be the only expression between variable and field deref. Like maybe this one wins, and maybe variable is just a subset of this iterative dot separated resolution, which is cool. So if we look at the other places identifiers pop up, well, in a function call, we can't call foo.x necessarily. We don't have a function type, so we can't call foo.x. That doesn't work. That doesn't work. Maybe one day that'll work, but right now that doesn't work. That's interesting though. Like maybe as long as the function call, like the thing that we're working with, is an expression that ends up... No, but there's complications here, right? Okay, I'm gonna put a to-do here as well. To-do is an identifier, the only thing we can call. Do we want other things that are callable? That would be interesting. That would be really interesting. The other thing that uses an identifier is address of. So we're back in this situation. We have two options, right? We could either add address of struct field, or we could try and change address of to work on a vec of identifiers and make it simpler, right? Make there be a simpler case. So I think this is the winner. We can't really do this in a smarter way, I don't think. I would like there to be a smarter way, but I don't think we can do this in a smarter way. What this actually means for an address of, we're going to have to change this. We're going to have to change this to do this awful thing from down here. This awful thing from down here. We're going to change this to fields. And then we have to convert them to dot separated things. Okay. And that's okay. So that was an easy change. But when we parse it, we're going to have to answer some hard questions. Or are we? Maybe we're not. Maybe we're going to have to answer no hard questions. Maybe this is actually going to be extremely simple. So now when we assign deref, the left-hand side... address of. My mistake, wrong thing. Now instead of just getting a name, we maybe just need a list of names. So let's look at where we do repeat one, like literally this, right? Literally this. So we get a name. What if we just do this? What if we just get a dotted list of fields? What's dotted field? I think dotted field is dot then field. Yeah, okay, so we need to parse one first. We need to do this first, and that's okay, S1, S0, S1, S2. So we get an address of symbol, the ampersand, the universal symbol, the universally recognized symbol of taking an address. We get the first thing, we get the rest of the things, we say fields dot insert, we put it at the head. I think that's how we do that. Or do these get swapped? I got them backwards. Did I? No, I didn't. Address of. Okay. We give it an index. We give it a thing that we're pushing into the list. So we're putting this into the head of the list, which is good. That's good news. And now address of just takes fields instead. So if I build this, what happens? It's going to yell at me somewhere. It's gonna yell at me somewhere. It's gonna yell at me here. I don't know why it yells at me here. It's expression struct fields. Did I accidentally change something somewhere else? Yeah, apparently I deleted an entire line here. That's kind of weird. Okay, that's really weird. Expression struct fields. White space. That's really strange. I don't know what happened there. Okay, we're gonna grab this. We're gonna paste it in here. We're gonna just quietly redo that as if nothing happened. This is gonna be from S1. This is from S0 still, which is good. We insert this. Now we're gonna give back an expression that is address of fields. Okay, that looks a little better. That looks a little better. ID not found in the scope, that's because it's called name. And also, actually, this is now a repeat 0. It might give back 0 dotted things. S2 is unused. Yep, that's good news. I love that Rust warns me about that, because otherwise I would be making that mistake all the time. S0 is an unknown field, so these are now fields. Okay, so what do we do in here? What do we do in here? Variable, we're gonna grab, yeah, it's called this. It's this big old block here. No, it isn't. Address of this big block here. We're gonna put a marker there. Okay, now I'm gonna quickly look at this. I'm gonna quickly look at this. Get field offset. This puts the offset of a field, of a list of fields, into a register. So I think actually what we want to do here, what we want to do here is not that tricky. It's not that complicated, right? Because let's think about this. What happens if we pass fields that are empty? Well, we're gonna load the offset of the first thing, right? Because we're kind of saying, yeah, we've got the first thing here, right? We're iterating over the rest of the fields. And we're kind of pulling out the head as a special thing. Actually, we don't need to pass the head name, do we? We can get rid of that, because that's here. And actually, so let's say fields.get, fields.first.unwrap. Okay, we are asserting that fields contains at least one thing by the time we've called this function. Always good to document these assumptions. Always good to write them down. Head name is somewhere in here. Fields. Actually, again, this should probably just return an error, except now instead of, well, maybe, again, maybe like up here we need to say let head equal. Let's do that. Let's do it up here. Let head name equal fields first. We get the first field, and then we're just going to unwrap it, because if there isn't something here, it's probably a parser error. Excellent. So now we're starting to generalize this, and this is the generalization that's going to let us combine that variable variant as well. So that'd be kind of good. That'd be really good. Head type, head name. Okay, we'll keep that there for now. Now let's find get stack field offset. Where's it used? We're going to get rid of the head name. It's just unnecessary. Now let's jump in, and we're going to use it here, because this is doing the same bit of work. All it does is get the address into register C and then push it to the stack. So we can call this function that gets the address of the thing, and then we just push it to the stack. It's kind of perfect, right? What do we need? We need to make a vec out, let out equals, not colon equals. That's my language. That's not Rust. I keep having this problem. So we're going to make a vector out. Fields, we have the fields. I don't even know if I need to borrow here. Var type. So we need to get the type of the overall variable. That is the type of, or the expressions. Is it? No, this is the type of, wait, get field offset. Var type. What's var type? Head var. Yeah. Okay. So this is the type of the first thing. We're going to do this. We're going to do this whole thing. Just do a good old copy and paste. It gets the job done every single time. Okay, so we have fields, we have var type, we have head var, we have the register we're loading stuff into, we have a nice cheeky little unwrap. We can get rid of this. We can get rid of this. And then all we do is add an unresolved instruction. And it pushes this, because this is the offset, this is the address of the field. When we resolve the value, we dereference this and then push the result of that to the stack. Here, we just push C to the stack. It's easier. Stack op push. Because every expression resolves onto the stack, as of right now. What happens when I build? Obviously something goes wrong here, right? Obviously something goes wrong. And this one's nice and simple. This one's nice and simple. It's very common to see in Rust, especially if you're not a big Rust head. Here, this can't be borrowed as mutable. That's because I didn't declare it as mutable. That makes sense. Okay, name.0 is an unknown field because these are now fields. Now, this is this same thing, right? This is, so maybe what I really need here, is a helper that is gonna get the type of a list of fields, right? Because this is gonna come up a few times. And let's do exactly that. Let's make, above our test, let's make a helper. Let's call it get fields type. So this is gonna take a context, which is a reference to a context. It's gonna take a scope, which is a reference to a block scope. And it's going to take fields, which is a slice of identifiers. It's not a slice of fields. That was a case of getting a bit caught up in the momentum of what I was typing previously. I think that goes in too. And this gives back a type. Not an error. Nothing can go wrong here. It's all good. If anything goes wrong, we just give back void. That's fine. So excellent, fields first, unwrap to string, perfect. Okay, this is good. So this simplifies this field deref. We just say get field type, ctx, scope, fields. Love it. In fact, we can simplify this even more. We don't need the braces. We can just put this here, field deref, and now when we get the type of an address of fields, all we say is get fields type ctx scope fields. All this other shit we don't need anymore. Identifiers, that is a case of pluralizing something in the generic because of course you do, right? It's a list of identifiers, so your finger just flies over to that S. Get fields type, kind of weird name, but that's okay. Now when I test this, it's all gonna work. Okay, a couple of things have gone wrong. Address of global panicked. Panicked 1079 code gen 1079. This is getting to be quite a hefty file, quite a hefty boy. Okay. Let's do the sensible thing here and turn this back into an error. I don't know why this was ever panicking. It made it very hard to reason about. Oops, not push. Very hard to reason about. All right, so what is going wrong here? Non-struct field reference X. X is indeed not a struct. So this is gonna be because, yeah. So we need to modify this a little, right? We want to say fields len is equal to 1. If there's only one thing here, we just want to give back... Yeah, this is fine. We just want to give back var type. No, wait, hold on. We just want to... What do we do here? What do we do here? Struct fields. Okay, so we do it after this. We do it after this. If var type is a pointer, so we push code to out, and then we get the fields, which is mutable, and that's cool. That's really cool. Mutability is cool. We love mutability here. If fields len is 1, we just return at this point, right? We just say, okay, we're done. Nothing else to do. And now this is going to work. Almost. Almost. We're so close. We are so close. So now we don't get the correct address of a global, which is weird, because what you would think would happen here, like it's not a pointer, right? Var type's not a pointer. So we match the type of the variable. It's a global. We should just load the address of the global, right? That's what we're doing. That's what we do. Load address 2. So why does that not happen? It's kind of weird, right? It looks like our code should be well behaved, and for some reason we get a 0. Weird, weird. What's the other test that failed? It's probably a similar thing, right? Let's just get this nice and big. Left equals right. Okay, so what test is this? Dref values local? Dref values local, that's weird. This isn't running that many instructions. Is this other one even smaller? Yeah, so let's start with the smaller one, right? Let's start with the global one. Globals are a little bit awkward in my machine because offsets are weird, but I think we've fixed all the problems with them. So let's go to our global test. Test pointer, address of global. This is the test. We'll grab this one. We're gonna go into test.code. We're gonna paste in this thing. We're gonna get rid of this other stuff. This is just our kind of dummy file. Where is my thing? Beautiful. We've got to delete some garbage that we print out because we declare a local. We need to set our offset here to 2 to match this. Actually, maybe what, 2? I think 2. It's kind of hard to know. Okay, yeah. If we see the stack pointer gets loaded correctly after the first instruction, we are happy days. Okay, so base pointer, blah blah blah. We jump to our main function. We load to... It's kind of weird we don't offset the stack there at all. I don't know. I guess there's no locals, so maybe we just don't omit that instruction. I thought we always omitted an instruction there. Oh no, it's here. This is, yeah, our labels are messed up. This is actually the start of main. I think this is okay, but something's gone a bit weird with our labels. This is actually the start of the main function. But in this case, I don't think it's a problem. No, it's not a problem. It's not a problem because we don't do any... Huh. Maybe it's a problem because we pop from the stack. Stack pointer, pop. Wait. Why do we pop? Why is the first thing we do here pop from the stack? That's not right. That's really not right. What the hell? Stack C. What is going on here? This is very, very wrong. This is awful. I can't even tell what's going on. Okay. It's like an entire instruction just dissipating between those two. I need to run to the bathroom real quick, and I'm going to ponder this, because this is a real conundrum. This is a real thinker. All right, we're back. We're back. I filled up my tea. Critically filled up my tea. What is going on here? What is going on here? So, in our main function, it really bugs me that this offset's wrong. This is also wrong. This is also wrong. Oh wait, no, this is right. This is right. Okay, I have to multiply it by 2. That's right. I forgot. I have to multiply my thing by 2. Now we're in. Now we've got the right highlighting and the right labels. So that's good news. That's good news. MC2 And then we pop from the stack, which is so weird. Like, we haven't pushed anything to the stack. So, in this function frame. So why do we get a pop? Why do we get a pop? So what's the first thing that happens? So this is an assignment, right? And I think the first thing we do in an assignment, if we go to code gen, assignment, we look up compile expression, yeah. So we build the expression on the right-hand side. So we're building address of, and this makes sense because this is what we just did, right? But why, how do we possibly, where does 2 come from? I just have a lot of questions. Where does the number 2 come from? Where does the number 2 come from? So we come in to address of, right? Fields is not empty. We have a thing. We get the first variable. We get it. It's a local. So we get the type. And then we call get stack field offset. So we're going to come down to this big old function down here. Get stack field offset. Okay? var type is address of int. var type should be address of int. And the block variable should be a local. It should be local 0. So this is our local. Load local adder 2. Okay? So we should see that and then a load word. Where's the load word? Register 0. So that's kind of like here, right? C0. So that's here. That's here. So what's this? What's happening in between? What other mysterious code are we generating when we start this function? What's 2? Hold on. Test.code. That's this. That is this. I'm just gonna copy and paste this again just to really make sure we've got the right thing. Because it's just kind of insane to me. What is this code? What is this mysterious code? Where is this coming from? Oh wait, no, it's declare, sorry. It's declare with an expression. This is different. This is different. Sorry. So we do a type check. We get the variable, can assign from whatever. We get the variable type. Otherwise, the type of the expression, that is okay. Else, what's the else here? If it's something, okay. If there is an expression. So we define a local, we compile the expression. Again, the first thing we do is compile the expression, which is the address of. So where does this pop come from? Unless it's literally here. Pop. Okay, so where does this 2 come from then? How are we compiling this expression into 2? Because it's a global, and the address of the global is 2. Ah, okay, that's more clever than I thought. So, actually, I guess that's kind of correct. So then what's this other stuff happening? So, I forgot that I was clever. It doesn't sound like me, but I forgot that I'd done something clever. If you have a global, when you take the address of it at compile time, it knows where that lives, because the compiler is responsible for allocating all of those globals. Okay, so that's good. That's really, really awesome. But I think we forget to push it to the stack. I think we forget to push it. That must be what's happening, right? Yeah, because in address of, we push to the stack. So what's going on here? How does this happen? How are we forgetting to push? Global, load address into the register. The address is 2. So that's perfect. That's absolutely perfect. So where on earth is this going? We put this bit, but we forget to push it somehow. somehow. So let's say declare, let's look at this again, declare, we compile the first thing we push into our thing. I won't do that right now, but I need to clean that up at some point. The first thing we push into our generated code is the compiled expression. Then we do this pop. So this is part of the compiled code. This is part of the compiled code. Compile expression. We're gonna, oops. We're gonna hunt for this, right? Because we come in and we have address of. We have an address of expression. Okay, so we make our out variable. We put the field offset in there. Ah, that makes sense. That makes sense. How did that happen? I know. I hope. Well, I don't hope. Someone out there is probably going to write me an angry comment because they noticed that. Oh my god, that's insane. That's really insane. I was just throwing this extra instruction away, so that's good. Like I was able to hone in on what the problem is in between these two instructions, but just kind of insane that I did that to begin with. If we pass everything now, oh my god, we pass everything. It just works. It just works. So we can get the address of struct fields. We can manipulate them. That's such good news. That's really, really good. That's so good. Okay, I'm gonna add another thing. I'm gonna add another type of thing. What did we do? What did we do here? We changed address of to work with dotted fields. So let's cargo format first, anticipating my pre-commit hook yelling at me. We're gonna git add lang address of takes dotted struct field. Let's just call them dotted fields because they may not be part of a struct. If there's no dots, it's not part of a struct. So they're just dotted fields. Excellent. Should I change variable to be the same? Because if we look at variable now, it's a little bit redundant. So if I do variable, it could actually just be the same as this with an extra load in between. With an extra load in between these two things. Does that work? Or I guess actually get rid of variable. If we get rid of variable, because lowering our surface area is a really good idea right now. The less space we take up with this code, the less duplication we have, the easier these changes are going to be to make in the future. Enum expression. Okay, so in other words, change field deref to be a part of variable. I think we got to do it. I think that would make sense. Cricket comes into chat. He is ready. He is prepared to be an angry stranger on the internet. The hero this stream needs. Thank you. I appreciate that a lot. No, what's happening is, I've got a couple of struct tests. So I did this, right? And this works. We can assign to arbitrarily nested fields in a struct and also return from them. I also, as a bonus, tested declaring anonymous structs in a nested way, which was cool. And we can also now take addresses of struct fields. So structs, I think they actually work. I think I can just say that structs work, which is incredible. But now there's just a couple of ugly things rearing their head. So I'm actually going to get rid of... I'm going to turn variable into a vec of identifiers, okay? And I'm going to get rid of field deref. So now when we dereference a variable, it's either going to be like b, or it's going to be like b.foo, or it's going to be b.foo.bar. something else, right? It's going to be the same code that handles both cases. It's just the case where there's no dot is going to be a special case of the case where there's a set of dotted fields. Okay? Excellent. So what we're going to do, we're going to jump back into our code gen. We're going to rename field deref. We're going to rename this to variable. And then we're going to find the one... Where is it? Expression variable. We're going to delete this one. This one no longer exists. And then all we should have to do is go into language parser. Yeah, and then expression variable, I think we get rid of. And expression struct fields, now becomes the default with this. So we change repeat 1 into repeat 0, in other words saying that the dotted fields are optional. Previously there had to be at least 1 dotted field for this to pass, now there are 0, so it's perfectly valid for there to just be an identifier with no dots. And if I build this, it's going to work, except for where it doesn't. What else breaks? This is now gone. Variable S0 expression variable. Oh yeah, so this function can just go in the bin. Tuple variant. Oh yeah, this is kind of funny. This is now just a variable. This is just a variable. Okay. That worked surprisingly well. Scope get name, type of variable. Yeah, okay, so wait, what happened to field deref here? This. Yep, I renamed that and then I forgot to delete the first one, which is good. So this is all wrapped up now in a struct field dereference, which is really nice. Block variable is now unused. That's really interesting. That's really interesting. I wonder how that happened. Mismatch types, fields first. Variable expected, vec identifier, found string. It's kind of concerning when import becomes unused. Like, that doesn't feel natural, but sure, I'll take it. Type of a variable. Oh yeah, and this is just fields now. And I guess we have to convert it into a vec. If I test this, it's all going to work still, because we've kind of... Okay, not quite. Breaks a parser. That's interesting. Expected a star. 3 times food times blah blah. Expected a star. That's weird. That's really weird. What else happened here? Expected a semicolon. This is when we have brackets. This is a bracket test. Is it? Assign deref. Huh. I wonder why that broke. I guess it's probably because if I get diff, if I look for expression variable, can I put this in less and expression variable here, right? So is that not? Oh yeah, okay, so we got rid of it from the left-hand side. Struct fields now has a much higher priority. So what if I put that back where variable was? What if I do something really, really silly? Oops, this should be in language. What if I do something really silly, right? Because previously, where was it? It was in between address of and bracketed. So what if I put it back there, right? But what if I just put struct fields in twice? Because we can try parsing that twice and fail. Same thing. I wonder what parser is triggering that. I wonder why that behaves differently now. So what happens? X. Z star. So when we hit this, we're expecting a star, right? That's our context, and it's low confidence. So 681. So right from the start, we're looking for a deref, which is weird. I wonder why. Well, I guess this is actually a case where it's just not sure what it's parsing at all. So this broke brackets. Why does it break brackets? Why does getting rid of a dedicated variable type break brackets? So it's trying to consume this. I don't get it. Struct fields. Let's just try a little bit of rearranging. Okay. So that was better, maybe. Or maybe it just died before anything got to happen. What died there? Expression brackets. Okay, no. That's just a Stack Overflow. So, at least this is consistent, right? I just can't see where this happens. Context. So what about this? This one looks more interesting because we have a medium confidence error, right? We're more confident about what we were parsing here. There's still no tag, but we're looking for a semicolon at the start of this. So this is 534. We're looking for a semicolon here immediately after foo. So what this means is it's mulching the function name parser somehow. And that kind of makes sense, actually. That kind of makes sense if we think about where this is positioned. So I'm going to put a mark here. I'm going to call this mark Z. So this can't come before cool because this now matches against, like, for example, this matches foo.bar, but it also matches foo. But function cool tries to match foo. But if we've already matched foo, then we can't match foo with brackets. So this has to come after this. It has to. So then what happens here? It overflows its stack. And it overflows its stack because it calls this because it's now recursive with this. So if I put repeat 1 here, it won't overflow its stack. It'll just blow up in some other way. It's weird. I would have thought this was okay. I guess dotted fields, it shouldn't look for. Ugh. It's annoying. It's really annoying. What we need is a copy of this without the struct fields. But then that doesn't work because, okay, what we need, and I've thought about this long and hard, what we need actually is to have two parsers, one for struct fields and one for a variable. And I know that probably sounds a lot like what we had before I deleted a bunch of code, but this one's going to be different. So this is going to be like this, except it's going to give back... Can I do something like this? Can I make a vec from a singleton? Let's get my docs up. My favorite terminal command ever. I love that I can get the exact version of this up. API docs for vec and new in from rust vec from new singleton. Oh wait, hold on, wait. There's a macro for this. It's vec. I always forget about this. I've done so much vec initialization without this that I forget it's there sometimes. So we make an identifier. We parse an identifier, and then we just give that back. Perfect. We give it back wrapped in a variable. So now, in between call and address of, we're gonna go expression variable. And I need to rename this function to expression variable. So this is kind of what we had. This is actually maybe a worse version of how we had this function before, but that's okay. If I build this, it almost works. ID. Okay, this builds, and it should pass our tests. Yeah, awesome. Somehow this still blows up. And that's a little confusing, because if we get diff now, address of struct field's cool. Okay, so let's try putting that before this. Overflowed its stack. Again, we're here. We're in this weird place. So variable, what did the variable parser do before? What did it even do? Oh yeah, hold on, I have to go through this. I find the pager extremely annoying for get diff. I don't know why. It feels like it misbehaves. So struct fields, cool. We added struct fields. Yeah, cool. So we actually changed nothing here, which is good. This now returns a variable, which is cool. This returns a variable. Wait, that's not right, is it? No, because that... Wait, why'd I do this? What am I... Because it's a field deref. Wait, what's happening here? What's field deref? I turn this into expression address of. Oh yeah, that's right. I just called it field deref, which is weird. Expression address of. Is this? Oh, there's a bunch of lines missing here. That's actually what happened. That's just a really confusing looking function diff. Okay, that's cool, that's cool. Expression variable, yeah, we mapped this previously. We mapped this into a variable, but that's okay, that's okay. That doesn't really matter. This is the same thing, we're doing the same thing, same confidence, same everything. Struct fields and this. Get an identifier, get a set of dotted fields, and give it back. So, what blows up here, sorry? Expression brackets has overflowed its stack. So there's an infinite loop. And this is why parser combinators get tricky, because sometimes you get these loops and it's not really obvious where they come from or where they're going. You could actually fix this by having a smarter state type that had some information that let you, you know, like some maximum depth, and it could be like, hey, I think we're about to die, and then you could make a more interesting error than just the panic when the stack overflows. Okay. Let's do this. Let's do something funny. Let's say let mark fields equal vec new. Let's not do the recursive part, and let's see if this works. And let's give back fs0. Does this still explode? It doesn't appear to run recursively forever, which is good. So the problem is here. The problem is that and it's weird that this has happened. It's really weird because this wasn't a problem a minute ago. I don't think I changed anything meaningful, but for some reason, this is now, Well, for one thing, we could try and put this down here, and let's see if this helps. And it still overflows its stack. Expression brackets. And what test is this even in? Threadx brackets. Tests compiler. So this test shits the bed. I assume because it sees a bracket and then it gets stuck in this little loop. I'm assuming this is a problem maybe with the binary operation, right? Because we do a binary operation, we go into dotted field, which looks for an expression, and that expression could be a binary operation. So we see x, we see plus, and then we look for, we start with, an expression, bin op, it's a left-hand side, followed by a plus, followed by an expression, which could be another bin op. So the left-hand side, when we look for struct fields... So wait, what if I just say dotted fields? No, it's not even an expression, it's just an identifier. There's nothing recursive here. Dotted fields, there's no recursion. No recursion. Still overflows its stack. Okay. Overflows its stack. This is so annoying. This is like the most annoying thing to try and look at, because if I look at all the changes in this file, like what has changed? I'm in the language file. I've changed the definition of expression variable a little, like not really meaningfully. I'm still just looking for an identifier and then mapping some stuff through it and giving back a variable at the end. Cool. And then when I get in this function, this is a very confusing diff, but in this function, I've changed the return type. That's all I've done. I haven't changed anything in the parser. And then here, okay, I'm gonna undo my comment changes so we can just see that it's literally the same. Was before call, right? So if we look at this diff now, struct fields call, struct fields call. I'm gonna cargo fmt just to make our diff even better. Okay, so now we can see. We redefined expression variable. I'm gonna move this above address of so that we can really see. So that it really just looks the same. I'm in a weird state now because, yeah, sure, that's okay. I'm just gonna reformat. Oh, for fuck's sake, hold on. How do I get out of this? No, what have I done? I'm just gonna quit and re-enter Vim. That was, I got stuck because I formatted, right? But it didn't really know how to. Normally if you go back and forward from a buffer, you can resolve that. Okay. Bobius, hey, how's it going? Welcome. Hope you're going well. We are deep in the weeds of structs. They work. They're doing really awesome stuff. However, there are a few small issues still. I'm trying to make some of my code a bit more homogeneous, and somehow this is blown up. And it's weird because I've hardly made any changes. Unless the compiler now does some stuff. Bobius, I think you missed 4 consecutive streams. This is my 5th consecutive stream of just building structs. So you've just missed structs. You've missed all of structs. Okay, so here's a thought. I've been thinking that my recursive descent parsers are the cause of all my woes. What if the thing that's actually overflowing is part of the code gen? Is that possible? It is. I mean, if I look at the diff. So let's just get stash real quick, right? And we'll run a test and we'll see that it works. Excellent. Git stash pop. Okay. There's a command to like reload. I can never remember what it is. Shame you missed some of it. Sigo Null, hope it's going well. Thank you. Yeah, it is, right? We have structs. They're very, very close. Like they work, and now I'm just trying to do some cleanup. I'm trying to do some cleanup. So if we look at this git diff, right? This is an important diff. Because we've really changed how variables are defined. Right, fields, this is okay. Oh. You've been converting a parser combinator library from C to Odin. How does that even work in C? I guess you can do function pointers, right? But it sounds messy. And yeah, the manual memory management, like holy crap. I literally cannot imagine what that would look like. Unless you just pass allocators around everywhere, which I guess is an option. But yeah, wow, that sounds like a lot. Okay, so we just deleted this thing, right? We just deleted it. Wait, is the loop possibly... I've got a theory. If I go to code gen, and I want everywhere we reference, so type of this, that doesn't do anything. Huh. Weird. Oh, hold on. Okay, I'm gonna take a quick breather and look at this code that Bobius has just linked, because that seems I'm just so curious. Parser combinators written in C, putting programming language, blah, 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 blah. Oh, wow. You define... Wait, does it actually use BNF? You got a window using the Win32 API working today with an event loop in Zig. That's really hard. I tried playing with raw Win32 APIs ages ago, and yeah, it's a bit maddening. It's a bit maddening. What is... So, do you define stuff with BNF, and then you have functions that respond to... That's quite an API. You don't need to use the BNF? Okay. So you make a parser. One of anything, satisfy. Yeah, and then you can use the amazing C function pointer syntax. Everyone's favorite. That's cool. I mean, that's really cool. Parser function, you give it a parser. Yeah, that's parser combinators. In languages such as Haskell, ensuring you don't import one type of data into a parser requiring a different type is done by the compiler. In C, we don't have that luxury. Yeah, because I guess these parsers are all just pointers to the same struct. That's fun. That's fun. Did I see the Matt KC video? I did. That was incredible. That was one of the best tech videos I've ever seen. Really sets a high bar. I would love to do something like that, especially like his little story that he told through it. It was well done. It was well done. But yeah, if you haven't seen that video, a guy ported .NET, a really old version of .NET to Windows 95, and it's incredible. MPC malloc in mpc.c. Input, blah, blah, blah. So what does it allocate? So it just calls malloc, right? Malloc n. But it can return something else. Memfull I. So yeah, so there's some context that has some memory with a fallback to malloc. That's cool. That's cool. And again, yeah, so it tries to, if it's not a MPC pointer, otherwise do some stuff. That's fun. That's really cool. I like it. I like it a lot. Nice. That's a nice bit of C. It's a nice bit of C. Allocate 64 byte chunks. Yeah. If I ever plan to do C and Zig, optional pointers are the same as pointers that can be null in the ABI. Optional pointers, yeah, I like it, right? So basically, you can say at a type level that a pointer is allowed to be null rather than the C default, where just null can infect anything. Anyway, you have a pointer. Null will sneak in. Let's jump over to resolve and just make sure we haven't done anything stupid, right? Because I think we have. I think we found our loop. What's the type of a variable? Well, we want to get the type of a thing with fields. What's the type of the first thing in this set of dotted fields? It's the type of this variable. What's the type of this variable? Well, it's getFields type. What's getFields type? We have to get the first thing in the thing, which we call again and again and again. So that makes sense. These were two types, right? So I had fields as a set of dotted fields and then variable as different things, and I piggybacked off of the fact that I could just get the type of the first thing as a field. Sigo Null gifting a tier 1 sub to Bobbius. Thank you so much. Bobbius, he is an avid viewer, and so I love to see him subscribed. I made, actually, just quickly, okay? Let me pull it up on another screen and drag it across. I made an emote. I've commissioned a friend. He's going to make some other stuff for me, but I've made an emote. I want some feedback on it, okay? I think this is going to be my first emote. Do you think you guys would use this? I'm going to call it Quit Vim. And then if you're watching a streamer who is struggling to quit Vim, you can help out. You can be really helpful. So I think this would be a good Twitch emote. I think that's appropriate. Yeah, so that would be fun. That would be cool. I'll probably do that after this stream. You got paid today. Love it. Oh, I've been talking. I'm in talks. You'll use that to tell him to give up. Yeah. Oh, I mean, no one using that is being polite. But it could be fun. It could be fun for a bit of cheese, and it could be fun, yeah, just to have. Lots of meme potential. Okay, so the type of a variable is not this thing anymore. We need another helper function. Get variable type. I guess we'll call it this, right? And we'll make it do the thing that the old version of this did. Bobius, I can't remember if you were here when I said that I got rid of a dependency here. There was another thing. I got rid of the block variable dependency. Like I got rid of one of my dependencies, and I was like, that feels weird. And it feels weird because it did this thing. So I'm gonna need that back. Var. Well, let's just call it name. Name, and it's gonna be a stir slice, and we're gonna give back a type. Okay, so we're gonna now call, instead of this, get variable. Actually, and let's just call it variable type. The word get is not doing much legwork here. CTX scope fields first. We're gonna unwrap this. We've got to unwrap this bad boy because we have made the assumption that we have at least one field. It's called outside, adjust your sleeve. It's called inside. It's probably about 12 degrees inside at the moment. Giving up costs an extra exclamation mark. True, but if they're doing Q exclamation mark, they've already decided to quit. I don't know. They've already kind of worked it out. Got here late, like just to leave. All right, we'll see where this train of thought goes. Cool. So we need to get the variable from the scope. We'll say scope.get name, and then we need to match whatever the block variable is. This is why there was an import that is now gone. If it's a local, again, this is this thing we were doing before. I think we have a type and we have an offset that we ignore. We give back the type. If it's a block variable arg, we have a type. We have an index that we ignore. We give back the type. If I look at my git diff, I can actually see where this was. I can see exactly where this was. So scope get. If let sum v, there's a sum. There's a sum. It isn't optional, so we can do with this. Except this is a compile expression. We don't care about that. Where is the type version? Here. Yeah, okay. T, type hint, and that's a T. Beautiful. Oh, and we need to think about symbols. Okay, I might try and copy and paste this, actually. We need to do with these dashes, but that's okay. We can probably just do that. Nice. They're gone. Now, also, I'm just going to wrap these in sum, because that's going to make it a lot easier. Wait, hold on. I want to do this. I copied too much stuff. Else if... And actually, yeah, we need the thing. So we'll wrap it all up like this. There's one curly brace too many. And that's it. This is the thing. Type closing delimiter is not correct. That does actually make sense. It's because I forgot to do that. And I need a ref. I need a ref to the first thing inside it, because that's how that works. I've misspelled some things. Excellent. Thank you, Cricket. That's good. There's good meme potential there. Okay, I've misspelled a lot of things. Context. What else? What have I misspelled? Variable type and get fields type. I really have misspelled it, haven't I? Variable. And I'll let the compiler find this. Now, block variable. So I said it. Everyone on YouTube will know. I said I felt weird about getting rid of this dependency. I should have listened to my gut. Field first. Fields first. get variable type. Oh yeah, of course. It's now just variable type, because get doesn't really mean much. Beautiful. Okay, now if I test, everything's going to work beautifully. Except for that one. Except for the tests that fail. Except for the tests that fail. Mouth sounds is brilliant. All right. We are. How has this happened? How has this happened again? Somehow there was subtly different behavior when we were just dealing with a bare variable, right? Like, what did it do? What did it do that was so different? Display for expression, that is irrelevant. Resolve, that we've now done again. Variable type. Okay. Scope get. No, that's what we just did. That's what we just did. We've got the language. Where's the code gen part? Did I go past it? Code gen. Okay, this. So when we have a variable, depending on what it is, again, we should just be using helpers for this, right? But we push the value of the local. We push the value of the arg. We push the value of the global. It's not that complicated. So what happens if we go into CodeGen? What happens? Oh. There we go. Mouth sounds. Mashup album by Neil. Yeah. Along with, oh yeah. I have heard of this. I haven't thought about it for a while, but I have heard of it. Probably thanks to my friends in the New Zealand Gamer Discord. Thank you for the reference, Bob. Yes, I appreciate being let in on the joke. Yeah. Cool. So what happens? Get field offset. And then we load it, right? Which is perfect. That's exactly what should happen. So get stack field offset. If there is only one field, what does this do? It's not a pointer. So again, we load the address of the thing, and then we just push it to the stack. I don't understand what has changed. So let's grab one of these tests. Let's grab one of these failing tests. Address of global. This is a nice simple one, actually. I think address of global. Oh, sorry, it's in pointer, not there. Address of global. Yeah. So this is the one I was playing with before. So let's recompile this. I've got a lot of shell history to get through. Cargo run lang. Get the annotated version, which is good. Yeah, no, when people say mouth sounds, I always get paranoid that my mouth's just dry and you can hear all of the weird noises while I'm talking. That's my first thought. That's my constant paranoia as a streamer. As someone that talks into microphones. Okay. So what happens? What's this doing? This is loading a constant, loading the address of a global. The address in this case is 2. So that's good. So what do we get when we run it? We end up with 0 in the A register. Okay, so we end up with 0. So we push C, and then we pop C, because of course we do. Who wants to be efficient? Then we set up B to be the address of the local, and we store it there, which is good. So now our local B has the value 2. So it's the return that is wrong. The return does not do the right thing. This is interesting. This is where we go wrong. This is actually literally just, this is it. We're getting the value of the global, which is 0, rather than the thing. We load twice in a row. Oh, cool. Couple of little bots coming into chat. Let me just quickly resolve that. Let me block them. They're gone. Sorry for the bots. Okay, they're gone. They're gone. Excellent. It's incredible. You know, you take your eye off the prize for a second, you get bots in your chat. They come in. They're brutal. So basically, what I'm returning here is actually the dereferenced value of B. So there's too many load words. It's too many load words. Now, is it possible that our return statement does something weird? Like this. No, wait, no, that's fine. That's the instruction. That's the instruction. Sorry, I misread the instruction. I misread what that one was doing. That is just this. That's fine. That's fine. So in between here and here. So this is, so we see an expression. We compile an expression. The expression is an address of. So let's look at address of. What does address of do? No, this isn't even address of. This is just variable. This is just variable. My mistake. We're on this line now. We're on the last line, right? What I expect to happen is we set up so we're returning, right? So yeah, we set up the register C with the address or the reference into the stack frame of the local, and then we load it. And I don't know why we load it a second time, but that's okay. Is that, so that must happen, stack push, load word. So it must be one of the things in here. And indeed, I know exactly what it is. It's this, right? Because we're returning a pointer. So I think this is just -2. I think this is just -2. As long as it's not the penultimate thing, we don't resolve the pointer. Now I think we work again. Okay, well, apart from the fact that that's kind of funny. I must have pressed VU by accident at some point. I love those accidental key presses. And I didn't save. Okay, there we go. So that's better, but that's still not right. That's still not right. And that's weird because it should be okay. We've got exactly the same situation, right? We've got exactly the same thing here, which is that if I is less than fields, if I equals, let's do this. Let's do it like this again. Because if we have a pointer, if we have a field that's a pointer, we need to dereference that pointer unless it's the last thing in the chain, right? If it's the last thing, so in this case, it equals fields len -1 would be correct. So if it's a pointer and it's not the last thing, we need to do another dereference. But if it's the last thing in the chain, we shouldn't dereference it. So again, let's see if we can step through here and imagine what's going on. Let's do a test again, just real quick, now that I've changed the logic. Cool, address of global fails. Let's just find the specific failure, make sure it's this, and yeah, so it expects 2, it gets 0. So we're almost certainly seeing the same thing. Again, just for posterity, just to make sure we're not chasing ghosts, let's be really thorough and recompile it, and we see the same thing. 2 load words in a row. 2 load words in a row. Not even good bots, exactly. These are the shittest tier bots you could get. I don't know who falls for it. I don't know who falls for it. They even posted the same link. 1 isn't enough. Okay. Did I just move something? No, that was okay. Don't panic. There should be a way to remove the messages, yeah, but I can. I don't have that window open, but I can. I should have it open. I'm really asking for trouble, not. But I'm not going to work that out right now because I'm in the load zone, the load word zone. If anyone does anything really bad, I will deal with it. But for bots, whatever, it's fine. They're gone. They're gone, and that's what matters. So let's step through this and imagine what the inputs are. Okay, so var type is int, is an int. On the increasingly frequent occasion you get timed out in people's chats, all your messages get removed immediately. What are you doing in people's chats that gets you timed out? What are you backseat gaming? Are you telling them how to play Overwatch? So test.code. So we're returning get stack field offset. So fields is just the identifier foo. The type is a pointer to an int. The head var is a local with index 0. So var type is pointer yes. Ah, this is it. This is it. If it's a pointer and fields len is greater than 1. So if it's a pointer and there are more fields, we need to do that. Otherwise, we just dump it onto the stack. Now we work. Now we're back. Perfect. That worked. Okay, so we need a comment here. We need to say check for special case of one field. Then we don't want to deref. I don't know if that's a good comment, but I think it kind of gets the case. E.g., let's write this one specifically. So if we have int let int b cool. Hopefully that reminds me of what this is. So that's good. That's good. We've just simplified our code quite a lot. If we look at our code gen file, you know, it's still over 1,000 lines, but it's much less repetitive than it was 2 or 3 streams ago. So let's cargo format first. Deduplicate. This is going to be a hard message to write. Let's go lang source in var that's fine. That's a fine message for now. Okay, beautiful, beautiful. I think structs are done. I think we've done everything we need with structs. That's cool. That's cool. So I reckon it's time to merge the branch. Now, some of you might say, awesome, he's going to go and make a pull request. And that would be incorrect. Huh. Okay, so I can't merge this apparently. So I'm going to rebase it instead. Wait, I did that wrong. Oh crap, I did that wrong. I was meant to rebase struct on main, then merge. I always do this. That should be fine though, right? That should have been a no-op because they have a common ancestor and all of the changes in struct. Let's find out. Let's find out. Okay. Git merge ff only struct. Okay. What happened? I don't know what happened there. Okay. I did something weird. So I did my rebase on the wrong branches and I can't work out where oh, hold on, here it is. So all that did, okay, and that's actually fine. That's actually completely fine. All that did is reorder. So that's cool. So I merged in. There's no merge commit. Well, I moved my changes into the main branch, right? There's no merge commit. All of my struct stuff is here, but the latest commit that I had in the main branch has gone after the struct stuff. So that's fine. The place where they diverged, right? This was the commit. This was the commit where they diverged. There was something in main that wasn't in struct. And because I rebased struct into main, but they shared a common ancestor, it worked out what to do. It just applied all of the struct stuff first, whereas the way I was going to do it would have applied all the struct stuff after. But that's fine. So it's weird that it says, oh, but now that one commit in the origin, my history's kind of ugly. I mean, no, I think merge commits are much uglier. I'm going to force push. Main because I think this situation now. So because I did that stupidly, now my remote is like, hey, I have this one commit. It has this commit, but it has it as a different commit hash probably. So I now have these struct commits and I also have this commit in my remote. How I unify that is complicated, but I think I can just force push. Do I do it? Do I do it? Do I force push? Let me do it in the other terminal so I can type my thing without getting stressed. Yeah, screw it. I mean, well, hold on. Here's the other thing. Can I cargo T still? Yeah, so we're fine. And obviously everything still builds if I can cargo T. We're going to force push. Should mute as well. Is this true? Is this true? Can someone acoustically work out my... I was talking about this earlier. Also, I use a very non-standard keyboard, so I don't know if anyone could even like could even work it out. Did that show up then? Can people see my nice, adorable little plank, my travel keyboard? Let's see. What does that look like in the GitHub feed? Oh no, you can. I've been caught red-handed. Everyone can see I force pushed. That's great. That's great. Thanks for narking GitHub. So what does it say? Yeah, so look, and these are just all the additive changes, right? This is all the struct stuff that I did, which is really cool. It's all done. That's all done. So that's great. So, and again, you know, if we come into GitHub now and we look at the commit history, for one thing, it says I just did this now, but I didn't. I did this a few days ago. But yeah, these commits are all quite nice. You don't get these weird, like I have merge commits in here. I have a merge commit somewhere. I did one by mistake. Or merge, here it is, merge branch better UI, right? Where is it? I don't know. I just find them messier. Oh, simply that the order wasn't right. Order doesn't matter. Unless you're doing like unless you have really specific auditing requirements, I don't know why you would care about the order of your Git commits, as long as they're all there and they all, you know, apply in a relatively logical order. The thing about this was so disconnected from everything else that didn't matter. And if it had a lot of conflicts, rebase would have given me a chance. You can just rebase. Yeah, that's what I did. If you missed the fiasco, I was in main and I rebased my branch rather than rebasing my branch onto main. It just meant that this one commit ended up out of order to how I actually wrote it, but it's so disconnected from everything I changed that it's fine. So that's cool. We did structs. Structs are done. We're gonna, once I fix this, hello? Do you want to show me my window? No? There it is. Really fix structs. We have done so much more than just fix structs. That's incredible. That is a very good, very productive stream. Start arrays. I think this is actually going to be a lot simpler. I think all the refactors I did today are going to make it really easy. I might add size of off stream. I might see if I can just quietly do it, because I want to try and pick up the speed a little now that the language is getting closer, so that I can do some streams focused on actually building things with it. I might also off stream try and get make some changes to my Canvas terminal, like my Canvas monitor, and try and add character rendering to it so I can do some fun text stuff on there, make kind of like a mirror, an echo terminal thing. That would be cool. But with 2 hours under my belt, I think now is a good time to call it quits before I melt my brain. Got a nice couple of viewers hanging out though. It's awesome to see some people. Orion Treat, you know, always nice to see a new face. Sorry you came in right at the end, but we will throw some love onto another streamer. Thank you very much, Orion Tweet, for the follow. Orion Treat, sorry, Treat. Have a good night. I mean, it's like 4:30. I'll have a good afternoon though. A good evening. So let's find someone good that we can raid. Let's throw these viewers on. Let's try and find someone cool. If anyone has any recommendations, I'm always happy to do it. Cricket says :Q a couple of times. This is good. This is good. Once right after this, I'm going to upload that emote, and then everyone who's subscribed will be able to use :Q. This is good. This is good. So, what is who's good? Who am I throwing our viewers onto? Who do we want to see? Who's good? Is anyone doing compiler dev? There's one. No one's doing compiler. No one's doing compiler. I mean, Program Alive looks good. That looks very minimalist, very chill. Horn game. No problem. Hope everyone's doing well, by the way. Hope everyone is surviving the outage, the incredible worldwide Windows machine dramas. It's all pretty wild. I'm glad I wasn't catching a plane yesterday. Oh, is the Kenny Game Jam on? I didn't realize. Rust streams. Is anyone playing Rust? Yeah. It was insane, right? And they pushed it on it was a Thursday, right? The funny thing is, if I try and filter Rust Rust programmers, it's gonna just give me people playing the game Rust, which is funny. Anyone I'm following on? No one I'm following is on. This is a different time than usual. I don't know any of these people. I don't know what's good. Innovation in machine learning. We could throw it onto innovation in machine learning. Game dev Q&A. Junior developer building a text editor. Let's try this. Building a text editor, Kotlin, Java. Let's throw some viewers over to this person. So sorry, that took me a little bit to find a suitable stream, but thank you all for hanging out. It's been a great journey. Structs are working. What more can I say? That's fantastic. That is such good news. And let's check out this streamer. Let's see what they're up to. So thank you all so much. Have an excellent night or morning, whatever time of day it is. Thank you to everyone who's following along on YouTube. I'll get that emote up right now and have a wonderful, wonderful time. See you next time. Bye.